see. Think we're recording? Yeah. All right. So on your quiz for Thursday. Again, probably not going to be, certainly not going to be much time, might not be any time for you to do a retake. You need to make sure you put some time in today. You might have a little time on Thursday, but mostly today. So that, I mean, it's kind of like it's extra important for you to be ready. Because if you're ready, and let's say you don't do great on it, but you at least get a 60, then you don't have to tutor, which means you probably will have time to do a retake. If you're not ready and you get a 40, now you got to try to get tutoring in and get the retake in by next Wednesday. Next Wednesday, 3 p.m., I'm done. No more grades. If you're absent on that day, that's too bad. Not gonna make exceptions. The only potential exception I would make, and I would only do this if I felt like you really truly put time in, is if it was this test you're taking Thursday, because if you only have 2 days, it's not like you really had a lot of time to take that in. But like for all the other quizzes, that one's due this Friday anyway, so that won't matter. But you did isosceles equilateral. You had this week. Well, those grades are in now, so you have the rest of this week. You have Monday, you have Tuesday. I won't be making any exceptions for that one. I think that was the only other one. Besides, we're going to take Thursday. So what's the, oh crap, and I should have told you this, hopefully you assumed it. What has to be true in this for us to even be able to solve it? Phones, earbuds, headphones, all that needs to be up. Sorry, which phones? And I don't like I said, I don't want to see any of it, because that's the only way I can manage it. As you say, I don't even want to see it, because otherwise I get all kinds of extensions. What has to be true? Like what? I mean, actually, it does tell you this. So even though I didn't write it, there is something that tells you this. I'm gonna call. Ellen, you weren't here. Can you tell me something about that figure? That's super important. We did do the lesson on Friday, from last third.
No, the line, the bottom line, it's with the other side alternating.
Yeah, I can't have you in here if administrator walks in or something. What do you mean by the bottom line?
The line that has point P on it.
All right, so JP, yeah, right down there. What about it?
Wouldn't that be 90?
So we know there's a 90-degree angle there. Again, if you don't know what to do, start with what you know. Well, I know there's a 90-degree angle. I see that. I know there's a 90-degree angle. I'll tell you something. What else do we know? You've got to call on Chloe. What else can you tell me about this? And I'm going to go ahead and say we know there's two 90-degree angles. So those we know. We think this is just visually. What do we see? I believe there's one up here. So what else do we know besides the two 90-degree angles? So these are about sides. Good. So I don't know like what X is. That will probably work. So I know that, oh, that's super big. I know that is about the length of some line in that figure. Which line would it be about? It's about the length of a line, where the only lines really it could be about. Yeah, it's got to be about the length of these two lines, right? Which visually, again, you can't always rely on the way the picture is drawn, but visually, it looks like they might be the same length. So you might be thinking, is there a way, or should be thinking, I can't say for sure they're the same length because there's no markings, right? There's no congruence markings. That's the only way I could know they're the same length immediately, is if it shows me like a little congruence mark. But I can think, was there a way I can maybe prove, like, is there something I'm supposed to know that would prove that they are the same length? So what else is in the picture, Isaiah? What about that middle line? Did I tell you it's a bisector? How do you know it's a bisector? Because I'll give you a hint. Did tell you it's bisector. I may not have written the word or Ray JS bisects MJP. I didn't write that, but I did tell you it's a bisector. This is the tricky part of this problem. You know, most of you would probably guess what to do, but if I ask you to explain something, then this is the concept or the understanding you need to have. How do you know that's a bisector when I didn't tell you it's a bisector? What do you think? I think. But I didn't tell you that. Like, how do you know? Not the right angles. So again, we still don't know that it bisects because I could still draw lines at the angles. So again, so if you don't think it looks like it, now you got to say, well, can I prove it? Well, it does. I'm not telling you that because I'm not that good visually to look at it and say, yeah, that bisects. There's something in there that's telling you it bisects. What's the definition of bisect? What else is in that figure that we haven't really talked about? So I heard Ray, and then I heard something. There is a big angle, but visually this is a little tricky in this picture, but I'll explain. You think you know? So that's actually two red lines. So this right here is really, it's really this. We'll do it in red still. So it's hard to tell because of the way they drew it. It's really that. That's what tells me it's bisector. So again, if you didn't see that because you thought it was one red line, I get that. But that's actually, there's no reason to put just one line through that, because again, that's a congruence mark. I don't ever write just one congruence mark on one figure. So that's two congruence marks that are telling me those two angles are equal. That tells you it's a bisector. So just keep it. Well, you could do that, but that wouldn't tell you anything. Like if I want to say the angle is 45 degrees, I mean, I can write that in there, but there's no reason for me to draw. I could just write the number. Like here, if I have just one angle, I mean, I can do that, but normally the reason you're doing that is to compare it to another angle. Again, there's nothing wrong with doing it, but if you see a figure and you see it in there, typically it's going to be talking about two different angles. Because I don't have to write that just to write, like if I want to write the measure of the degrees or whatever I would do, I don't need to write that to say, well, that's a 45 degree angle. Like I don't need to put the thing. Normally, again, it's not 100% of the time. Normally though, if you see markings, they're called congruence markings. That's why we put them in there, is to show that angles are congruent. They're equal. Well, in order to have two things be congruent, you got to have two things. So if you see those marks, if you need to write that note, write that note. You see those marks, you need to be thinking that there's two angles that are being compared, that are congruent. Now, we sometimes in a figure will do this, and we'll put markings like that, and none of them are the same, but that's why we're putting them. We're putting them to show that none of the angles are the same. So we're still comparing angles, just they're not congruent in that case. So the normal reason you're going to see those markings is if you're comparing angles. You got to be thinking that there's more than one angle if you see those markings. So now that I know it's a bisector, what's the concept here? Ben on this one. What's the concept that they're telling us? Like, what are they using in this? Well, but how do we know that? What's the concept? And again, a lot of you would probably guess that's the equation, but if I make it a little more challenging to figure out, you need to understand why we can make it that equation. What's the concept we learned about bisectors? And it applies to a perpendicular bisector and to an angle bisector. Get it for both of them. While you're thinking, I'm actually going to draw. What is it about bisectors that's important? Actually, arguably the number one thing that's important when it comes to a perpendicular bisector. Now you remember, again, this is what you better be practicing because you will not get another shot at this. What is important about bisectors? Again, if I'm calling this a perpendicular, I'm telling you that's a perpendicular bisector. It could go on forever. It could just be a line segment. Doesn't matter. This is also a bisector. It's an angle bisector. What is important about bisectors? If you can just remember this one concept, it's kind of the same for both types of bisectors. Well, it splits this in half, but that's the easy one. That's just in the name. There's another concept they're using here. Say it again. There are 90-degree angles, but that doesn't help us. Why can we, most of you would guess this is the equation. But if it's not as simple as this, you need to understand why I can do that. Why can I do that? What tells me, what is the concept? What's the theorem that says this line has to be the same length as that line? Because these are about the length of the line, right? We talked about that the other day. So it's something I have to know why those two lines are the same length. So what's the concept about a bisector? Because the bisector bisects the angle. The bisector bisects the angle. So why can we say those two lines are the same? It's the concept we learned, and we learned it for both types of bisectors. Nobody? All right, so again, this is a big one. This is really the only, you should know that if it bisects it, it splits it in half. I'm expecting you to just know that. That's just a name of it. That's the definition of a bisector. Splits it in half. It either splits that line in half if it's a perpendicular bisector, or it splits the angle. That's the easy one. The one you got to remember, the next connection you got to make, which this is the way all of geometry works. There's a concept that is like the basic concept. That's the one that should kind of just be intuitive almost from the name most of the time. But then there's oftentimes a second concept that's a little tougher. In this case, any point on the bisector, whether it's a perpendicular bisector or whether it's an angle bisector, any point on that bisector is the same distance away from kind of like both sides. In this case, the sides are the endpoints. So those two dashed lines are the same length. That point is the same distance from here as it is from here, if this is a perpendicular bisector. This point on the bisector is the same distance from this line as it is from this line. And again, we draw distance, or we measure distance at a 90-degree angle. That's why this is important, that we have 90 degrees. That tells you we're measuring the distance. So because of that, because we know it's a bisector because of these markings, because we know these are 90-degree angles, that tells us we're just measuring the distance from each side, and the distance has to be the same if that point is on the bisect. So that's a big concept you need to understand from bisect. Some of it will be easier, like if I just asked you like what we did the other day, I just asked you something about the angles and I gave you the measure of the big angle. That's the easy stuff. This would be the kind of thing, this concept would be the kind of thing that got you to B's and A's. The other stuff will get you to passing and C's. Let's see. So if you solve that out, remember whenever you have variables on both sides, you have to think about getting rid of them on one side. Don't try to combine them and say that's 9x. See that every once in a while? You have to think, because if I said, well, I'm just going to add 6x over here to combine them. What is the number one rule of algebra when you solve equations? Yeah, whatever I do on one side, if I want to add 6x here, I have to add 6x here. I cannot just add it on one side. So that doesn't do me any good if I try to combine them that way. Yeah, it just gives me more x's on both sides. So you have to think about getting rid of them on one side. It doesn't matter which side you get rid of them. I could subtract the 3x, I could subtract the 6x, I'm going to subtract 6x. So now, again, if I want to get x by itself, I need to get rid of the 5. You should kind of know how to do it from here. So negative 12 is negative 3x, divide by negative 3, divide by negative 3. And if you solved it out, you should have gotten x's. And then, depending on what they asked you, which they did ask you for the length, so be careful. They didn't just say solve for x. Anytime in geometry, especially, anytime you solve for a variable, make sure you read the question. We would need to, now, I can, even though they're asking me for SP, I could actually plug it in here. Because they're the same length, remember? That's how we solve it. We know they have to be the same length. So if you want to plug it in here, because that's a little bit easier math, you could do that because you're going to get the same number. Yeah, calculator, so it really should be 4 times 3 is 12. 12 plus 5 is 17. Just to make sure, let me plug it in down here. 4 times 6 is 24. 24 subtract 7. Now that I've checked both of them, I feel pretty good about the math. What's that? So we solved, we got x is 4, right? Well, the length of this line, or this, we'll say this line, so that's the one they want. What is the length of that line? What represents that line? Yeah, that's this. Again, don't worry about how it looks. That is the length of that line. So if that's the length of that line, right? Well, I know what x is, right? Well, I just plug x in. And then that's what I say. Remember, this is just some number. This is just some number. Once we solve for x, we can figure out what that number is. But until we solve for x, we can't. But it's just some number. It's just the length of the lines. All right, so that's one piece of your quiz on Thursday. The other piece will be what we did last class. So if you weren't here, we did a problem still with this kind of figure, but it was about the measure of the angles. Whatever this angle was, has to be the same as this angle if it's a bisector. And then we did like little plus little is big in that particular problem because that still applies. These two added together still have to add up to the big angle. We did a new lesson on very basic stuff on triangles. I'm not even going to go through that. You can watch the video. It's posted. Today we have a new lesson that we'll do, and then you should be able to review and do. I'll assign the problem. I haven't assigned problems from all the lessons yet. So then you should have quite a bit of time to review, practice on your own. I might do some problems up here that people have questions on. Any questions on that one though? I know you missed a class, so you can kind of try to use today to see where you're at. The lesson we did the last class was super easy. We did it in like 10 minutes, maybe not even. Let's see. All right, let's just go to the next problem. I think I have some more problems from the book. I'm here. Okay, do not read. Remember, they're solving for you. Do not use all of that. So in your book pages, I don't know what page it's on. It's example 2 back in the perpendicular bisector stuff. Here, so it's before the triangle stuff that we here we go. Actually, not perpendicular bisectors, it's angle bisectors. Again, yeah, angle bisectors. We're going to go into the book in a minute. So it's page 354. The same page that problem was that we just did, actually. So go to 354. Try to do that example there. So again, don't read the solution. Just try to solve for angle ZYW. That's what they want. So just try to solve for that without reading the solution. You need to read the solution, you can, and then try to do the check problem right below that. After, oh wait, why is these? So after that, we will. After that, we'll just start going through some problems. We'll go all the way back to perpendicular bisector.
Yes, Terry. He's over there.
Oh, we did out new news. Yeah, so the grail books from over there, they're the ones that should have them. Check and make sure it was 345 through 402 before you walk away. Just make sure they're in there. It's 354, I think. Give you, I mean, that's a pretty basic. Actually, yeah, that's super. You should be done already with that problem. You're not even solving it.
What page?
345 to 402. So again, this is way easier than I expected it to be because the last problem was a little tricky. I'm not sure why they all of a sudden gave you this super easy problem. Let's just go over this one and then we'll go back to the perpendicular because this is not, we need to get the practice problems. This is way easier than what the quiz will be. If I know, well, here's the concept in here. So the solution is not the hard part. Again, making sure you understand what the concept is that the picture is giving you is the hard part. So again, what do we know in the picture? Shot A, what do we know in the picture? So we know this. How can I do that? Let's use skinny line. That is 5, right? That's what that 5 is talking about. What else do we know? So we know we have 2 lines that are the same length, right? That's what we know. What else do we know? Who can I call on? Leslie, what else do we know? So they're also 90 degrees. So what's important about the 90-degree thing? Why is that important? So why is a right angle important in this? What's the right angle elements? Anybody know why they're drawing the right angle? We're not doing this. They're not. No, which one? That one. Oh, you got 345 to 402, I believe. It's the rest of the month. I feel like we tore them out. We tore them out Tuesday, though. Were you not here all week?
No, I'm pretty sure it's Thursday, because I'm here Tuesday.
Oh, all right. I could have, I don't know what we did on Tuesday. Maybe we used the last few pages of the other section. Does anybody know why that right angle is there? Again, it's the same concept we just did. Why is the right angle important? Again. Sure. So you have to remember this. A right angle can tell you or tells you that that's the distance between those two points. We measure distance between points at a right angle, or really distance between lines, I should say. So we've done this many, many times. If I have two lines, I have a point on this line, and I want to know what is the distance between that point and that line. Like we actually did this in one whole lesson. You don't want to say, well, the distance from here to that line is that long. You don't draw, because otherwise, how would you know which direction to pick? How would I know if I go way over there, or way over there, or way over there? There's only one way to measure distance, and that is at a 90-degree angle. So when you see something like that, it's telling you that's the distance between those two lines. So what it's telling you is this point is the same distance from this line as it is from that line. So again, that's why it's called using the converse of the angle bisector. They didn't tell you this is a bisector, right? They didn't draw in the little markings. But they kind of did tell you it's a bisector. If this point is the same distance from both of those outside lines, then that middle line has to be a bisector. It has to split that into two equal angles. That's what allows you to solve. So the answer is there's no real math on it. You just have to understand that concept. The answer is just 38 degrees. If these two things are the same length, these have to be the same angles. If these are the same angles, these have to be the same length. So remember, I told you it's kind of like an isosceles triangle. If the two sides are the same length, then the two angles are the same measure. It's actually almost exactly like it. If these two sides are the same length, these two angles are the same measure. That's one you need to make stars by and memorize for the quiz. If the sides are the same length out here, the angles are the same measure in here. If the angles are the same measure, then the sides have to be the same. All right, so that was really no math. You just, again, have to, that's a concept you've got to have down. So I'm not going to spend a whole lot of time on that. Again, they're telling us these sides are the same length. So they didn't give us numbers this time. They're just giving us congruence marks. If these sides are the same length, what is true? The angles are the same, right? They have to be the same if the sides are the same. Make sure you memorize that. It actually forms a specific figure that we go over later. It's called a kite, where these sides are the same length, these are the same length, and then that's dividing it in half. Is there any other way to help you with that? And again, technically it would have to have 90-degree angles there also. I don't see them trying to trick you and not make it a 90-degree angle. So, all right, so let's go backwards and we'll start assigning some practice problems. We might do some of the examples also. So turn back one lesson to perpendicular bisectors. Go to 346. We'll probably do that one up top. Yeah, there's no, I mean, there is a little bit of math. So 346. Whoop. Hold on. Yours. Taking a minute. There. What's that? That's not what we're in. Oh, wait a minute. Oh, wait. Wait. Huh. What? Oh, that's way back. So that is the chapter. So we'll come back and I'll assign the practice problems. All right, so there's your problem. Again, you would only have that. I don't think they tell you. Oh, they actually do tell you that FG is a, oh wait, no, they don't. So again, don't use the solution. That's all you would have if I gave you this problem. So all the other stuff they're talking about is they're already solving. You just get that picture. And it would say, find the measure of something. What is X or something? She is not. So, with that in mind. Isaiah, you need to see this, bud. Isaiah, you need to see this, bud. We're into problems now. What is this? Again, what do we know? Camille, since you're awake. What do we know? Tell me something we know. So that's always important when you see congruence modes. Oh, I can't do it. So we'll just do this. When you see congruence marks, they're giving you that for a reason. Very rarely are they ever going to just put incongruence marks. So they're telling us what? What does that mean? I haven't called on Zoe yet. Zoe, what's that mean? So I just put in congruence mark, or they have congruence marks in there. I just kind of highlighted it. What's that telling us?
That they're same length.
What is? Use your letters or use their letter.
Points between.
Well, the segments EG and then GH are the same length, right?
Yes.
So the fact that they're the same length is what's important, but you kind of have to think of it as in a little different way. And we also know what else? What else is in there? Then we know there's a right angle. That is also extremely important. So what is the concept that they are using here? Hang in there, Hal. That's all I'm saying. What's the concept? Why is it important that we have those congruence marks? Similar to what we just did in the angle bisector, and they had some congruence marks in either the angle or later they had them in the line segments outside. It means they are, but how do we use that? What's important about that in this? What do you mean both sides?
About lines, H, F.
So that would be where we're going. But why are they equal? Why can we say they're equal? Because again, most of you would guess that because you're so used to just setting two things equal to each other. Sometimes it's right, sometimes it's not. So you have to understand why that is correct. What did we just say when we're talking about distance, length, and perpendicular bisectors and points that are in between things? Again, told you it was the same when you had a perpendicular bisector, so I'm going to draw it for you over here. So that, again, it's not a perfect drawing of it. What is true about that point if that middle line is a bisector? It's the same distance. We said we just did the same problem, basically. This point, if this is a bisector, then it's the same distance from those two lines. Or we could say the opposite is true. If we know, because I'm not telling you it's a bisector, but if I tell you those are the same length, then that line has to be a bisector. the same thing we just did, only we're doing it for a angle. So if I'm telling you this is a 90-degree angle, that point is the same distance from those 2 points, then that line has to be a bisect. Every point on this line, every point on GF has to be the same distance from E and H. That's the concept. That's what a perpendicular bisect. So you've got some memorization to do before this quiz. There's not tons of topics, but if you don't put time into it ahead of time, I'm telling you, your last grade is gonna hurt you. For those of you that are borderline, probably gonna fall on the wrong side of that borderline. Borderline means like you're close to a grade, either you're one above it or one below it. So just, again, whenever we get to the end, it always scares me because no matter how much I drill home that you have to really prepare for this last quiz, kids don't always do it. So again, if this point is the same distance from these 2 endpoints, then and you have 90 degrees, every point on that line, it's a bisector. Every point on that line is the same distance from the 2 endpoints. So that's how we can say these are congruent to each other. Well, if they're congruent to each other, then we would just set the 2 equations equal to each other. 4a subtract 15 equals a plus 12. I'm not going to solve out the algebra. You can practice that. I can check. We'll have time today. Go ahead. I think there's a check problem below that. Oh, actually, no, there's not. So try to figure out what's going on. So again, it says it's the converse of the perpendicular bisector theorem. So look at what's going on. It's pretty similar. So look at what's going on, and you probably would guess the correct answer, but think about what's going on and how you use the concept we just went over. Example 2 is what you're looking at. Remember also Friday's the deadline for quizzes. On Friday. So it was the solve for angles and triangles, and then the like proving triangles congruent, SSS, SAS, ASA, all that stuff. Oh, they've already solved that one for you too. All right, so I'm just gonna go ahead and do this one, the same thing. It's not really any math in this one at all. So what is the concept here? Start with Friday on this one. What's the, or if you don't know the concept yet, what do we know? We know W to Y is the same distance. What tells us that? Well, what? I don't see anything that tells me anything about this.
That's
You say WY? What about WX? Use letter, bunch of points. You gotta be specific. So this is something that costs you guys on your, when I say to explain something, I don't know. Again, the explanation has to tell me you understand it. When you just say the points, there's like 4 points. So I'm gonna push you more when you answer questions because you need to be able to repeat this on questions where I say explain stuff. So W, there is something about WX. So what is it about WX that's important? Look at the numbers. Now, these are the same length, right? Which means, and I think this is where you were going with it, but again, you got to be able to say it correctly, because if I give you one question that's explained, which is a pretty good possibility, you got to be able to explain it correctly. The distance from this point to X is the same as the distance from W to, so for the recording, the distance from W to X is the same distance from W to Z, right? Well, we just said if we know that there is a point on a line that is the same distance from, so these would be endpoints, right? And that line it's on is at a 90-degree angle to that. Again, just think about the name. It's a perpendicular bisector. Every point on WY is going to be the same distance from X as it is from Z. Every point. So if we pick any point, I could pick this point out here. This point out here, once I know one point is the same distance, every point's the same distance. So all they got to do is tell you one point is the same distance away. And it has to be at a 90-degree angle. That is. So this point out here, that's the same distance from both of those. I don't know how far it is, but because I know this is the same, every point on that line is the same. So with that in mind, this is a point on that line, right? Y is a point on that line. It is the same distance from the two endpoints, just like this one was. It has to be. Well, if I know they're both congruent and I know what this one is, what is XY? That's the same. It is the same distance. Z to Y is the same from X to Y. I just totally drew that. I drew it to the letter X instead of the point of X. So it has to be the same distance away. So I'll tell you right now, here's how the question's going to be on the quiz. Either I'm going to ask you to explain something, so you got to understand it, or I'm going to give you way more information. I'm going to give you information everywhere, and you got to pick what the correct things that are going on. So it's not going to be like this where they really only give you one. I mean, I don't know what else you could possibly put there besides 22.4. Or in the other one, there was only one way to do the other, is to set those two things equal. So those would be easy. You'd probably guess your way into the right answer. It's going to be tougher to do that on the quiz. I expect you to have at least some understanding of what they're talking about and how to set a problem. All right. So we didn't do example 3. We skipped over that lesson, so we're not going to do that. So with that in mind, turn to 349. I think all we're going to do. Oh, no, that's fine. Ooh, I kind of like 13, 14. Didn't do really anything. So 11 through 14. So 1 through 6, 11 through 14. What color? We go back to blue. Page 349. This was perpendicular bisect. So I'll let you work on for a minute on that, and then we'll move into what we're gonna do for angle bisectors. So I'll give you like 10 minutes to work in that. Try to do it. They're not. Some of them are pretty simple. Keep in mind, I'm going to go more toward 11 through 14, but you got to understand the concepts. 13 and 14 are about the concepts. So make sure you look at those and see if you can figure those out too. Can't really stop the recording for those lessons.
No, I
Over there. Again, before you walk away, just make sure they're in there. It's 345 to 402. Sometimes, as you know, it's tear them out and put them back in the same pile, which
5 to 1.
345 to 406. And, you know, like I said, before you walk away, just make sure they have that section. It's right, it's all the way at the back of it. It's the last module. And it's well, we tore them twice. We tore them out twice. We tear out a tiny section and we tore them out. We have to use a tiny sections. Yeah, I was confusing, so it was tiny sections. Yeah, we just. Yeah, well, we actually skipped over something that was in this section. We just, the big section we tore out. Got to come back to. Yeah, on that. Yeah, absolutely. Whatever's in front of it. So when you're solving for variables, remember what's ever in front of the term, whether it's a variable, whether it's a number, whether it's a number with a variable, whatever's in front of it is glued to that. Talked about that. I'm pretty sure we talked about that when we solved before. You have 3 subtract 5x equals 10. Well, you subtract, that's supposed to be subtract 3. Let's see. Oh my goodness, what the world? Subtract 3, 7 equals, you've got to bring that negative down with the 5x. So gotta bring the negative down with whatever is behind it. And then when you divide, you have to bring, a lot of kids forget this too. When you divide, you have to bring the negative down as well. All right, so let's. These are so easy to just guess the correct setup. I wish they would make it. Because this is not the way the district's gonna do it. I guarantee that, or the EOC. I don't think. So in a number 11, I'm just gonna give you the answer, and if you did it, you got a different answer, let me know. I'm just gonna go ahead real quick. It looks like number 11, x is 7. And then let's see, that would be 54. Looks like maybe x is 18 and 12. So there are your answers. You can try to solve. Again, you need to understand why you're able to set the equations up. Like I said, there's really only one way to solve it. You would have there's no other variables anywhere in there. There's no other equation. So you would all probably guess that's what you do, but you need to understand why you're setting those equal. Again, it's because the distance, if we see that that line is at a right angle, which it says that, if we see that there's a point on that line that is the same distance from both endpoints, then that means every point on that line is the same distance from both endpoints. That's why you can set those things equal.
Oh, okay.
6 seconds.
7 was the answer, x equals 7, and then for 12, it was, what did we say, 18? Yeah, but again, guessing isn't gonna be enough on the quiz. Not to get like an A or B, you probably will be able to pass, like, just guessing what to set up. You gotta understand why you're able to do that. And that would again be because every point on a bisector is the same distance away from either the lines, if it's an angle bisector, or from the endpoints, if it's a perpendicular bisector, which this is a perpendicular bisector. It's splitting this line XZ, it's splitting XZ in half. So therefore, that's what allows us to say this is 22.4. That's why 13 and 14 are pretty good ones to think through. I want you to think through them. I'm not just going to give the answer. All right, so now let's go to the angles chapter. And we'll do a couple examples there, and I'll give you some problems you can work on. And we do, well, I might. We'll see. I might save the brand new lesson for Thursday, right before the quiz, because it's a little harder than the one we just did, where we talked about the size of an angle is related to the length of the opposite side. It's a little tougher than that, but not a lot tougher. Well, I don't know, maybe. Angle bisector, we're not doing that. Assign those. All right, angle bisectors. I don't know if there was any exam. Oh, we kind of did that for the bell work. So again, the key is you need to understand what allows you to set certain equations up. These you would just guess, I'm sure, make those equal. You can guess that all the time, even when that's not what you're supposed to do. But you need to understand why. And we already went over it. It's because these two little marks, and I'll make it more obvious that that's two separate marks on the quiz. Those two marks are telling you that's an angle bisector. So if it's telling you it's an angle bisector, that means every point on that line, if this line is bisecting that big angle, every point on that line is the same distance from the two outside lines. That's what allows you to set them equal. This is the opposite. We already went over this one, but because that those 2 points, Z is the same distance from W as X is, and because that's measured at a 90-degree angle, meaning we're measuring the distance between the lines, if that point is the same distance between the two lines, then the angles have to be the same angle. Only way. And you can like just think about it. Like if I drew a line way down here, right? Horrible line. Clearly that's not an angle bisector, right? I drew the whole thing. Well, that's kind of neat. Shoot. All right. I do it again. A little more time with it. So, towards mine. So there. So clearly that is not an angle bisector. Those angles. All right, so this is your one warning for the day. Put your phones up. I don't want to see them. If I see a phone, watch out. We're going to be under that for the rest of this semester. Just get used to it. That is clearly not an angle bisector. We did not split this big angle in half. This is a much skinnier angle than that. And clearly, a point on this line is not the same distance from both lines, right? I'm close. Well, let's do this. So I have this. Clearly not the same distance. And not the same measure. But as I change that line, as I change that line and I move it more toward the middle, the way that works. Yeah. So if I change it, I kind of move it more toward the middle. I'll draw it in the middle. So now it's a little higher, right? Again, still pretty clear visually. I didn't split it in half. And still pretty clear that those are not the same length. But as I move that line closer and closer to the middle to where it's a bisector, this line gets longer, this line gets shorter, and eventually when I put it right in the middle of the angle, these two lines will be the same length. So if that concept, just visually thinking about one line getting shorter, this top line keeps getting shorter and shorter, this one keeps getting longer and longer. As we move this more toward the middle, maybe that'll help you kind of to get that concept down. It's the same thing if a little tougher to draw. So let's draw it here. If I have that, well, clearly, and again, it's perpendicular, it would have to be perpendicular. That line, you can probably tell is visually shorter than that line. And I can also tell this is not in the middle, like the middle is more over here. So as I move this red line to the right, this line's going to get longer, this line's going to get shorter, and eventually there's a point where they'll be the same length. Well, that point where they're the same length is when it's exactly in the middle there also. So it's the same concept. As you move a line that splits an angle, as you move it more toward the middle, these lines get closer to the same length, and eventually when it's right in the middle, they're the same length. Same thing here. As I move this line closer to the middle, it's eventually going to make those two the same length, which means every line is the same length. These two down here will be the same length. If I had another point on here, once I moved in the middle, those two would be the same length. So again, very conceptual. Some of you probably had no problems visualizing it. Some of you, it's going to be a little trickier. So you're just going to need to put some time into doing a little studying and maybe even memorization of these different concepts. All right, so now the problems. So look at, I did all, most of those. And I think we did all of them. So go to the practice problems. Again, they're pretty easy. They kind of just only gave you one option. I will put more information in there and you will have to figure out what is it that you need to set equal to each other. One thing that will be important is how do we know if one of those little expression, and again, an expression is just something like this. That's an expression. It's got variables and numbers in it. Doesn't have an equal sign yet. You have to create the equation yourself using the expression. How do we know when the expression is about an angle versus a side? Degree symbol. I'm telling you right now, you better hammer that home in your memory because I'm going to put some stuff that I give you the measure of angles and I give you the measure of the sides, and you got to figure out which ones go with which in order to set up an equation. Make sure you remember that one. That'll certainly help you kind of eliminate part of this. So definitely one. So page 357. So you can write this down. Page 357. Blue. So page 357, 1 through 6. Those are like the easy problems. Yes, 15. I don't feel like that's. Oh, actually, 15 and 16. I really like the 16 one. So the 1 through 6. Fourteen through 16. That's it. 1 through 6, 14 through 16. And again, 16 would be the one that would be about concepts. So see if you can figure out how you would explain 16. What page did I say that was on? This was angle. Here's. All right, so I'll give you like 10 minutes to work on a couple of those. And then I'll do a super fast review for those of you that were not here last class of what we learned, which really will only take 2 minutes. And then we'll do the brand new lesson. Probably just introduce that and then we can go over it again on Friday before we practice for the. You should have plenty of practice time. Keep in mind that you need to understand concepts, don't just be guessing at equations and solve them. You need to understand why you can set the equation up. Try to create something that we can use later. Oh, I don't want to do that. Shoot. What? Give me another minute to work on that section, and then we'll kind of wrap up all the lessons. I'll review what we did last class, and I'll add the last lesson. Yeah. Check one out. Yeah, I have those. Those are for in class only.
What do I, check.
All right, so you want me to like it? Yep.
I read it back after that.
Actually, I don't think that's how she's supposed to be. All right, so last class we did a brand new lesson. Told them it was the E. So if you weren't here, so Kellen, pay attention. Go back to that doing that stuff in a minute. I told them it was the easiest lesson you will ever do in geometry. I really believe it's the easiest. I mean, I may have said we've done easy lessons before, but correct me if I'm wrong, those of you that were there, it's the easiest thing I think that we could possibly do. We said if we have an angle, we have two sides, and imagine that we actually have a triangle, not just an angle. So that is closed off. We have a triangle. We said if I opened that angle up, that side would have to become longer to finish the triangle. Triangle, you know, would have to have a third side. So what we basically said is that the relationship between angles and sides is that the smallest angle, again, if I closed that angle down, it would make the side smaller. The smallest angle is always across from the shortest side. But again, as I close an angle, it makes the side shorter. So the smallest angle is going to have the shortest side. The biggest angle, largest, biggest, whichever way you want to think of it, largest angle is across from the longest side, because again, as I widen an angle, I'm making the other side longer. So if one angle is wider than another angle, the opposite side has to be longer. And then we said that I just called it middle. You can make up whatever you want. The middle sized angle is across from the middle length side. That was the whole thing. And all they had to do, or all the book had to do, is put either they had you put the angles in order from smallest to largest, or the sides in order. The only possible tricky thing to this would be if I gave you, and I don't even remember if we got to this in this class. If I give you a triangle and I say, I want you to tell me what the order of these sides is from smallest to largest using the angle measures. So I want everybody to do that. Put the order, the sides in order from shortest to longest. And you, by the name, like naming a side would be AB, AC, BC would be the three sides. So put those in order, smallest to largest. Really nothing else I can do on that lesson on the quiz. There's no, and I guess I could use some variables somewhere, but I'll just tell you I'm not. I'm just gonna give you numbers. You just gotta either put the angles in order based on the length of the sides, or you gotta put the sides in order based on the measure of the angles. Pretty sure that's, I'm looking to make sure, I'm pretty sure that's all. I'll give you a minute to do that. They did some word problem stuff that actually are pretty good word problems, but. Oh, actually, no, they did some stuff on 15 and 16. Just trickier algebra. On top of that. All right, so again, what's the concept? What is the thing you have to understand? The thing just repeat what I just told you. Who am I gonna call? Isaiah, what's the concept? Isaiah, wake up. What's the concept? Lesson yesterday. Yeah, man, you guys have got to get this one correct. If anybody misses this one, you're below it. It's the easiest, like I said, easiest thing we've done all year. If I have a triangle, I have the measures of the sides, so we'll start with the sides. Or just in general, what is the relationship between the angles and the sides? Look at the figure on the right where I've kind of done for you. Wait. Can you hear yesterday? We talk about them, triangles and their angles and sides. Yeah, so what is that figure, since the head was down, just explain that figure to me. What am I saying? So again, as we make an angle bigger, the other side, the opposite side has to get longer, right? Like there's no other way to do it. So in a triangle, the really skinny angle would have a very short side. The angle that would be bigger would have a longer side. So the biggest angle, that's the largest angle. The side opposite is the longest side. Now you would have to have numbers to determine that. I'm going to give you a triangle where they all kind of look the same. So you're going to have to use numbers. So with that in mind, how do I do this particular problem? I want to know which one is the shortest or smallest angle, which one is the largest angle. What's the first thing I need to do? So how do I do that? You can't just look at it, you need numbers, but what's the problem? We're missing one. So you might think, well, wait a minute, how do I know if 51 is smaller than B? Or how do I know if 61 is bigger than B? What's the problem? Or what was my solution? Remember, all the angles of a triangle, the interior angles, have to add up to 180. So they may not have written anything in there, but I can find out what it is. I can solve for it. because 51 plus 61 plus that angle has got to add up to 180. So if you do the math, you'd have 180 and then you would subtract 112. So what would that be? 68? Is that what you got? So if you do the math, then you know this is 68. Now you have all three angles. Now you just figure out which side is the shortest, middle, and longest from the angles. So first of all, what's the smallest angle? So across from 51 then is the shortest side. So that's it. And then you do that for all three. I normally go straight to the largest. So across from the largest is the longest side. And I do want you to write this out. So this is not the way you would solve it. And then the middle side, middle length is there. So now that I've labeled them, I can say, okay, well, if I need to write them, shortest, middle, longest, BC. And then middle is BA. I don't care which letters first. That doesn't matter at all. So that would be the answer. Put them in order from smallest to largest. After writing. AC is not. AC is the longest. The 68 is the biggest angle, right? Got it? So again, that's the only even remotely tricky part. If I give you the sides, I have to give you all three sides. There's no way, unless I gave you a right triangle, which I'm not going to. So if I give you all the sides, that should be easy. There's no math at all. You just put them in order based on the side lengths. If I give you angles and I don't give you all three, you just have to remember that you can solve for the third angle if you know two of the angles. So you just need to go ahead and solve for the third angle. Now, once you've done that, you just put them in order based on which angle is smallest, middle, and largest. All right, so the last lesson for the quiz, and we'll review this before the quiz. What's a triangle? Three sides. We wouldn't say prism because prism's 3D. Three-sided polygon, that's I think the word you're thinking of. So here's a definition you probably maybe never even got. But you probably did get it, but I wouldn't have even remembered it, I'm sure, when I was a kid. A polygon is a closed figure. That's very important in this particular lesson. What a closed figure means is that all the sides are touching and there's no like extension, like perfect. Like there's no extension, like a line can't extend past one of the vertexes. Also, they have to touch. Like this isn't a triangle. Like that's not a triangle. They don't touch. So it's got to be closed. There can't be like extra stuff hanging off the end. So if I do a rectangle, it has to be like that. This is not a rectangle. That's not a rectangle. This is not a rectangle. Like that's not a rectangle. Or if that's that way, like I mean, it sounds like a weird thing, but it comes into play in this lesson. So here's my question to you. I gave you 3 sticks. Yes, I gave you 3 sticks. Yes, I did. Can you create a triangle? Never. Why not? Well, why don't you just close it? It's open, just put them together and close it. So we need to kind of wrap this up or I'd spend more time on it. There's actually an interactive thing. We just, as you know, we go super, super fast. So I'm going to just draw out. There's one of my sticks. Here's one of my sticks. And here's one of my sticks. Make it very obvious. So I have those 3 sticks. If I take those and if I attach them to the ends of this to try to make a triangle, am I going to be able to close that off? No way. No way that's a triangle. Now, let's say these become a little bit longer. Am I going to be able to close that off? Still don't feel like that's going to work for me, right? Gradually, though, as I make these longer and longer and longer, probably extend a little more. At some point, I'm going to be able to close those off, right? I may have to change the angle, like I might have to move this out a little bit, but at some point they are going to touch. Anybody know what that point is? What is the rule that you, so basically we're coming up with a rule for when you can make a triangle versus when you can't. Like the borderline right in between of when you can and when you can't. What would have to be true? Girl. That should be our referral right now, and I hate not doing a consequence when I've just made a big deal out of it, so you might find yourself surprised one day about that. So think about what would happen if they're not long enough, and I tried to close them off. What would happen if they, so I'm trying to get them to close, and what would happen? So they would be closing down, and they would miss each other, right? And they would just land flat on the line. So they might land flat on the line. I'll make them in red to kind of help. So one would fold down and fold to there. The other would fold down, and they would miss each other all the way down and just land flat. So what do we need to happen with them? Eventually, what do we need to happen in order for them to stay in a triangle? No, nothing about degrees. This is not about degrees. This is about length of line, length of sides. What was that? Maybe we'll see it again. So say same. What do you mean by same length? Getting closer. Shorten the bottom. Can't shorten the bottom. Can't, no, they have to be at the endpoints. What do we need to happen with these 2 lines? So as we close them, we need them to hit. So what has to happen? What is the rule basically in order for us to be able to make that triangle? In order for them to hit, what has to be true about it? I'll give you another hint in a second. Oh, we're getting super close. Someone sort of said that. So let's say this. What do you mean? Well, what do you mean by same length of thing? No, these being the same isn't necessarily the requirement. We can build a triangle and have, one side that's way shorter or longer than the other. Let me give you some numbers. That's 10 down there. That's a 5, and that's a 4. When I fold them down, are they going to hit? They're not, right? Because 5 here and 4 there would be my lengths. Well, they're not long enough to hit, right? There would be a gap in between them. If I folded them down, they would miss each other and go all the way down, and there's a gap. We can't shorten this one. We wouldn't want to shorten those, because if we shorten these, that would just, like if I shorten this one down to 3, let's say. Oh boy, that's gonna be hard to do. So if that's 3 and I change that to 3, I just missed by even more, right? Ooh, so what if we made them longer, even one of them longer? If we could make one of them longer, and as we close, eventually, like if I made them really long, think about if they're super long. If this is 10 and this is 10, well, if they're 10 and 10, they're going to hit way up top, like as I close it. So now let's think about this. What if we made that 7 and that one 3? So what's going to happen as I close them? They are going to hit eventually, but where they hit, so this would be the point where they hit because they're 10, right? They equal 10. So they would literally fall right on top of that line that is 10. Still don't actually form a triangle. That's one line on top of one line. So what do we need to happen? It's 3 and 7 didn't work because they're the same length as the bottom and they just fall right on top of the bottom. We don't add a fourth stick, but you're getting closer. We need to do something with, oh, that was. So here's the rule, and we'll do this more before the quiz, because this is going to be on your quiz. So if you want to try to look at problems, probably not a bad idea. So the rule is the two shortest sides of a triangle, in order to make a triangle, I should say, the two shortest sides, and you could write the sum of the two shortest sides. I'm going to write the two shortest sides added together. Must be more than the longest side. Oh, must be more than the longest side. Or greater, you could say must be greater than the longest side. So if 10 is the longest side, if the other two sides, when you add them together, are greater than 10, they will have to hit each other on the way down because they're greater than this, right? If I folded them all the way down, they would overlap. If they were like, if I tried to lay them all the way down, if they're greater than 10, which means in order for them to hit right at the tips, I'd have to raise them up a little bit. That would be what forms a triangle. So again, this is on your quiz and it gets more complex. I don't know how tough I'll make it on the quiz though, but there is something where you have to know, well, what is the range of possible values that would allow me to make a triangle if I had a 3, I'm sorry, a 7 and a 10, what is the range of values that would allow me to make a triangle? And it's a little tougher. It's not just a matter of saying, oh, well, anything, like it just has to be greater than 3. There's another value that comes into play also. So actually, I'm going to do that right now really quickly. So what else could happen? Like if I want to make a triangle and I have a stick that is 7 and a stick that is 10. Oh, that's wrong one. It could be greater than 3, like I could do one greater than 3, right? But what happens if I have a stick now that's 20? So that's greater than 3, right? Is that going to make a triangle? Why not? We just said, as you know, if it's greater than, I'm sorry, it'd have to be greater than 7. I'm going to write 7. Again, we just said as long as those two shorter sides are greater than 10. So if I make it like 4, 5, 6, but if I make it 20, why is that not going to work? Well, now I've changed the biggest, right? 10's not the biggest anymore. Now this is the biggest, which means these two added together would have to be bigger than that. So again, the biggest side could flip. You don't always know which side the biggest side is. So you got to take into account that this may not be the biggest side. So if it's the biggest side, then we have to be greater than 3. But if the other side is the bigger side, then these would have to be bigger than the other side. Like the other side can't be bigger than these two added together. So the highest number we could have for the other stick would be sort of 17. So we'll finish that up, but make sure you practice all the other stuff so we can work on that enough on Friday. Get it done. I hope you are gonna work on your own. Start doing a lot of that. Alright. There will probably only be like one difficult question per quiz grade on this one. Cause there's just not, we've not that. Yeah, there's just not that much to do in some of this. We should be fine for the whole time. Alright. Come on in.
For the triangle, test quiz that we did, I got 100